Okay, so this is the solution to problem 334, and your textbook asks you to find the resultant and x bar, which is the location of the resultant. Alright, so let's start by first taking this distributed load and turn it into a single load at a single point. Alright, so normally we call that W is equal to 200 pounds per foot times, and that's over a distance of 8 feet. Okay. So when I do that, I get, and it's in the negative direction, so let's not forget that, negative 1,600 pounds. Right? Okay, now where is that located? Right? And when we look at this, first we have to come down the full 8 feet, and that distributed load will be at the center of this uniformly distributed load. So it's 8 feet long, half of that's going to be 4 feet. Okay, but it's not 4 feet in from point A, it's 8 feet plus 4 feet. So it's going to be so it's at 12 feet. Okay, now R is going to be equal to negative 1,000 pounds minus 7,000 pounds minus 1,600 pounds. Okay, so that gives us R is equal to, if I do the math correctly in my head, 9,600, oops, negative 9,600 pounds, right? Okay, so let's look at this and see that we basically have turned these two forces and this uniform load into one force, but now we need to find where that's located on this 12 feet beam in an equivalent system. Alright, so to do that, we need to find x bar. Okay, and x bar is going to be equal to the sum of the moments at A, that whole thing, okay, divided by R. Okay, so now if I look at this, okay, I want you to be sure you see what I'm talking about here. A moment applied here, if I put my imaginary thumbtack in A and I'm holding it down, I push here down, that's going to tend to cause this bar to rotate in a clockwise fashion about A, okay? And we say that counterclockwise is positive, so that would be a negative moment, alright? So let's look at what that looks like. So x bar is going to be equal to, alright, we got 1,000 pounds times 0 feet. Okay, then we've got, now this 7,000 pounds is going to cause a negative moment, so it's negative 7,000 pounds. Okay, the negative is there because it's going to be a negative moment, not because that force is in a negative y direction. Okay, 7,000 pounds times 8 feet. Then we have minus, okay, remember we've turned this force into 1,600 pounds at 12 feet, okay, so 1,600 pounds at 12 feet, right, and all that divided by negative 9,600 pounds. Okay, now look, this makes sense because this is going to be a negative number. This top part, the sum of the moments about A, is going to be a negative number, so you're going to get a positive distance from A being the 0 point. Alright, so let me crunch punch that out in my calculator, and I get 7.83 feet. Alright? And so let's just think, does that make sense to me? Well, yeah, that's possible, because I do have this large force, and it's about in the center. There's no moment due to this point because it's applied directly at the point. The distance is 0. So that's entirely possible and seems like a good enough answer. Okay, so just try to think about when you're solving a problem, is that answer unreasonable? All right, well, hope that helps.